Hello everyone, welcome to section 4.4 on reaction yields. We will be splitting this section up into two parts, one on the limiting reactant concept. We'll talk about that first in this video, and then there'll be another one on the percent yield concept. So in terms of this recording, you will be learning about the first learning objective, explain the concept of limiting reactants. Notice I left off theoretical yield, as that will be covered in the subsequent video. Before we start, I want to just remind you that you need to have mastered the material in section 4.3 before starting section 4.4, because section 4.4 builds very strongly on the material from section 4.3, and it won't really make sense to you unless you have mastered that material. When we talk about a chemical reaction, we can talk about it in terms of what are called the stoichiometric amounts. So how much we have of the reactants and products based on the stoichiometry of the reaction, which again is the coefficients that show up in the balanced equation. To this point, we've assumed that the reaction just always happens, and we've usually been focusing on just one portion of the reaction. We'll say, well, sometimes we don't have just one thing, we have more than one thing, and that information might affect how we proceed. So with the limiting reactant concept, what we're looking at is we're looking at the idea that if you have more than one reactant, you can assume one of them is limiting, or you can figure that out if you're not sure. And a way to understand this concept is, again, by making a food analogy, as we've done kind of throughout this module. So making a grilled cheese sandwich requires some cheese and some bread. So we can write kind of a chemical type equation, something like a chemical equation for that, where we're looking at the recipe as a slice of cheese and 2 slices of bread to make a sandwich. And the number of sandwiches you could make will depend on both the number of cheeses and the number of breads that you have. So again, this is our basic recipe, or similar to a chemical equation. Let's say we're given 28 slices of bread and 11 slices of cheese. What can we make with that? We can make 11 sandwiches because we have 11 cheeses, and then we would have some leftover bread because for every cheese we need 2 breads, and we have 28 breads. We would need 22 cheeses, so we have 6 leftover pieces of bread. So in this example, we would say that the cheese is the limiting reactant. It is limiting how many grilled cheese sandwiches can be made. In another situation, you might have, less bread, and that would be the limiting reactant. So this is the basic idea. Which of the 2 reactants is going to limit how much you can make? We can apply the same idea to a chemical reaction, and we can talk about something as being the limiting reactant, the thing that limits how much you can make, the thing that is not going to have any left over, and then also the excess reactant. So what is the thing that is left over when the reaction takes place? So how we would do this is we have an example where we have 3 moles of hydrogen and 2 moles of chlorine, and we want to decide what is the excess reactant, what is the limiting reactant. In order to do this, we need to think about, well, how much of the product can we make given our situation, and then think about that and see which of those is the smallest. So in our situation, if we have 3 moles of hydrogen, we're making 2 moles of our product per every mole of hydrogen. So we would be making 6 moles of the product. And then if we look at the chlorine, if we have 2 moles of chlorine, we would be making 4 moles of the product. So what we do at this point is we compare these. So we started with 3 here and 2 here. We end with 6 and 4. Whichever of the product amounts is the smallest is the amount that we make. Whichever one is the largest is then going to be the excess reagent. So in this case, we would say, because this amount is smaller, whichever reactant we were doing the calculation on to get that amount is our limiting reactant. So the Cl2 is limiting, and then the H2 would be excess. Here we're showing something that is not actually exactly what we started with, because we have, instead of 3H2 and 2Cl2, we have 4Cl2 and 6H2. So we basically just doubled the amount. I'm not sure why they didn't make these consistent from here to here. So this is what we have before the reaction takes place. When the reaction goes to completion, all of the limiting reactant will be gone. And by gone, I mean it has reacted. So the chlorines have all reacted to form HCl. And we can count, we would have 8 here. But we still have some H2 left over. Okay, so the Cl2 is the limiting reactant. The HCl is the product, and the H2 is the excess reactant. Okay, so you want to be able to do these sort of calculations where you determine how much of the product you have for each of your reactants, and then from there determine which of them is the limiting reactant. So here is an example. You can work through that on your own. In addition to doing this in terms of moles, you might, for the homework, have to do it in terms of mass as well. There will be a video showing how we go through this process for an example, if you would like to see another example, and then also proceed on to the rest of section 4.4.